Alright, so I just wanted to give just some general feedback on the benchmark. I haven't gotten a chance to go through and grade all of them in detail yet, but I just kind of wanted to make sure everyone's sort of seeing the big picture. Seems like most people have this, or at least everyone in each group has this basic big picture, but I just wanted to make sure everyone is okay with it. So, what we have this car, call it car 1, is skidding. Alright, so obviously it had some, V initial for car 1. And it skidded, and right before it hit car 2, it was still moving, though not as fast. Sorry, that's still car 1. And before it hit car 2, it was still moving, but not as fast. And figuring out what's happening when it skids, well, if we think about the force diagram for the car when it's skidding, imagine it's a side view, is it would have some weight, it would have some normal force, and then there would be some friction force. And you know that the friction force is related to the normal force. Alright, and we know that the normal force and the weight are balanced. We also know that from this net force we can get the acceleration, right? Because we know that the net force, which in this case is just going to be the friction, will be equal to ma, but we also know that friction is equal to coefficient mg. So hopefully you can figure out what our acceleration should be. The big question mark is this mu. That's where you're going to have to do some research. And for some of your cases, a high mu would be beneficial. For some cases, a low mu. So because even for some given surfaces, it can have a range. So find good resources, document them, and really think about what if you can support a good number for this. Alright, so what we would have for this, it would be a kinematics piece. We would have an acceleration pointing back that way. We would have a delta x, and we have a v final and a v initial. And we can get, so we're trying to find probably how fast he's going, so we're looking for a v initial, and we can work out some information about the v final. So what happens is this car skids, it hits car 2. Okay, so what's happening is this is what is happening before collision 1, or I'll call it collision A. Okay, so collision A is where 1 hits 2, and then what's going to happen is they are going to be a crumpled mess, mashed up car 1 and car 2 together. And then what's going to happen is after the collision, they will move off with some v final from that collision. Okay, but what happens is now they are going to skid together and come to a stop in the intersection. Alright, they're going to come to a stop in this intersection. So once again, if we can figure out how fast they're going after the collision, then if we know the acceleration that they're going to experience when they're sliding, and we know the length of the skid marks, and we know that they come to a stop in the intersection, then we can figure out how fast they were going after then that can be related to how fast they're going after the collision, which can be related to how fast car 1 was going before the collision, which can be related to how fast car 1 was going when it came around the curve. Again, you have to make some assumptions about car 2. Was car 2 just sitting at the stop sign, and was he rear-ended? Was he moving? Alright, these are things that you want to try to think of in your case. The last piece is that we have this car 3 that's going to come and hit car 1 and car 2. So car 1 and car 2 are just sitting there. And what happens is car 3 does not try to stop and comes in, and this is where our second collision is going to happen. Alright, so this is the before, we'll call it for collision B. Alright, and then what happens is after the collision, we can use our collision physics. Alright, so we have cars 3, 1, 2, and after the collision, they are going to skid off with some V, and then they're going to have their skid marks, and then they will come to a stop. We know how fast.
If we know about their V final, we know how long they skidded for, we know information about the acceleration, we can work backwards, figure out how fast they were going when they started sliding, then we can go backwards again and figure out how fast they were going before the collision. So major concepts we've got working here is we have our, like we said in class, we have our collisions. Alright, so that's our momentum conservation. We have our forces. That's relating our forces with Newton's second law, with acceleration, Newton's second law. And we have our kinematics, so our 1D motion. Alright. Now again, there's lots of things that you don't know. You have to make some assumptions about what various cars are doing. I mean, this guy's coming around the curve. What was car 2 doing at the stop sign? Why didn't car 3 try to stop? What is the coefficient of friction? What are the conditions? Okay, so there's lots of, even though the core of the physics is going to be related to stuff that we've done, there should be enough stuff that you don't know that you do have to research, that you do have to find some information about for you to make your case.